Okay, continuing from the previous video clip. So suppose if we have this equation, 5x1 minus x2 plus 2x3 is equal to minus 4. And the second equation is 2x1 minus x3 is equal to 3, and then minus x1 plus 3x2 plus 7x3 is equal to 0. So how we can represent it in the vector format? So like we did before, so we have these three variables. Okay, so x1, so we will treat these variables as scalars. So this scalar will be then multiplied by this first column of those coefficients, 5, 2 and minus 1. So this will be the vector, and then the next scalar will be x2, and then that will be multiplied by the middle column, so minus 1, and then no x2 over here, so it will be 0, and then 3, and then plus x3, it will be 2 minus 1, 7, and then equal to minus 4, 3 and 0. Okay, so that will be the vector form of the system of equations. Okay, so next question. Okay, so another example. So not only the system of equations we can write in the vector format, but if the system of equation has solution, or more specifically the general solution in the form of some free parameters, then that general solution can also be written in the form of vectors. So suppose if we have this system of equation, 2x1 plus 3x2 minus x3 is equal to minus 2, 4x1 plus 5x2 minus 3x3 is equal to minus 2, and minus x1 plus 3x2 plus 5x2 plus 5x3 is equal to minus 8. So this system of equation can be solved for its solution, and in fact we have already done it in the one of the video in the for the Gauss Jordan and Gauss elimination method. Okay, it was the, I think, the last one in that video, and then we found the solution for this was x1 was 2 plus s1, x2 was minus 2 minus s1, and x3 was s1. So if we want to represent this solution in the vector format, so it is easy. So we can represent these vectors as x1, x2 and x3 in this vector format, and then we can, because this is a two component solution, 2 and s1, so we can also write it in the form of two components, so 2 minus 2 and 1, and then for the second one we can take s1 as common, so s1 as common, and then its components are 1, minus 1, yeah, actually its solution was 2 plus 2s1. Okay, so S1, it will be 2 minus 1 and then 1. Okay. 2 minus 1 and 1. So because then in this case, in this case, then we can write it like 2, 2 and 2 minus 2, and then I think I have made a mistake over here because for S1 that component was 0. So 2 minus 2 0, and then it should be 2 minus 1 and 1. Okay, so then it will be S1 and then like that. So let's take another example for representing the general solution. So suppose we have the equation like x1 plus 3x2 plus 3x4 minus 5x5 is equal to 5. Then it is x3 minus 6x4 plus 10x5 is equal to minus 7, and then 3x4 minus x5, 4x5 is equal to 6. So for this equation, for this set of equations, we need to find the solution. So let's find the solution using either the Gauss-Jordan or Gauss elimination method. So first of all, we write the augmented matrix. So the augmented matrix will be actually a 5 by 5 matrix. In this case, we have 5 variables, and but on a second thought, I think I can see that it will be much easier to solve it by the direct method. So maybe I try, because writing a 5 by 5 matrix and using the Gauss elimination method may be too much. I think that actually we don't need. So I decide to use a more direct method. So in this case, if I see that, what is the equation? Okay, so in this case, as I can see that I have 5 unknowns but only 3 equations. So this means that I will need 2 free variables, S1 and S2. So I assume that x5 is equal to a free variable, so S1. S1. No, rather I should choose S2 actually. It will be easier actually, because for the others one I can choose the S1. So S2, okay, I choose S2. So if x5 is S2, so from this last equation, which is the simplest of the other 2 equations, so I can get x4 will be equal to, so because this will be 6 here, 6 plus 4s2, 6 plus 4s2 divided by 3. So it will be 2 plus 4 by 3 s2. Okay, so it will be 2 plus 4 by 3 s2. And then now in this case, we already know the x4 and s5. Okay, so I can find the value of x3. So x3 will be equal to 6s4 plus 6s4, 6x4. So 6 times 2 into 4 by 3 s2. Okay, and minus 10x5. So minus 10 s2. x5 was s2. So simplify. Let me simplify it. So 6 times 2 is 12, and then plus that is 8s2, and then minus 10s2. So it will be minus 2s2. So 12 minus 2s2. 12 minus 2s2. It will be the value of x3. Yeah, but actually -7 was also here, so I should add -7. So 12 minus 7 is 5. Okay, so it should be 5 minus 2 as 2. 5 should be 5, and then this was 8, and then that is minus s2. So we now we already know the values of x3, x4, and x5. So in this first equation, so we have we can input the values of x4 and x5, and now we can assume the value of x2 as equal to s1. Okay, because there is no other way we can. So we can take x2 is equal to s1, and then in this way we can find the value of x1. x1 is equal to minus 3x2 minus 3s1. Then it will be minus 3 times x4. x4 was this 2 into 2 plus 4 by 3 s2, and then it will be plus 5x5. So plus 5 x5. So x5 was s2, and then plus 5, this plus. So we can simplify it. So minus 3s1, and then it is minus 6 plus 5 is minus 1, and then this is minus 4s2. Minus 4s2 plus 5s2 is, that is, plus s2. So now we have these solutions in the form of x1, x2, x3, x4, x5. So these will be the we can represent it in the form of the vectors. So for example, like this, now we have this solution x1, x2, x3, x4, x5. So this is the 5 by 1 column matrix, or 5 by 1 vector. Okay, 5 by 1 vector. So what is x1? x1, so we can take x1 as 3 component. Okay, so it is -1. It is we can take -1. For x2 it is it will be 0. Okay, and then for x3 it will be 5, and for x4 it will be 2, and then for x5 it will be 0. Okay, so this will be one vector. We want to represent it into the vector form, and plus and plus s1. So for s1 is only in this first in the second one. So it was in the first it was -3, and then in the second one it was 1, and then 0, 0, 0. And actually I have left very small space over here, plus s2. It will be s2. For s2 it will be 1, and then for the x2 it was 0, and then for x3 it was -2, and x4 it was 4 by 3, and then for x5 it was 1. Okay, and then the bracket closed, but I don't have the space for that over here. So in this way we can represent this solution in the vector format. Okay, so I'm almost at the end of this video clip, so I will have some more examples. So this I will continue in the next video clip.